Hey guys, welcome to the channel, and today I'm going to be doing the plunger for the plastic injection machine. And if this sort of thing interests you, why not consider subscribing? It doesn't cost you anything, but it's really going to help the channel out. So let's have a closer look at the plans. Okay, so for the plunger, I'm going to make it out of brass. I think this will allow for less chance of it getting stuck in the actual chamber to similar metals. And yeah, this is basically, let's call it the, well, it is the plunger. There's still going to be a connection rod between the plunger and the pneumatic press on the top. So this is obviously just the plunger part. It's going to be 40 mils long. The actual part, the plunger at the bottom there, will be 10 mils. It'll be 18.25, but this is actually not an accurate measurement here. This has obviously got to be fitted to the chamber. So that'll probably more or less be 17.5 or just slightly under that, because obviously it depends on the chamber, and because I used a 17 mil drill to do the chamber, that'll obviously have to be fitted to the chamber. Then this part over here will be 16 mil, and I'm going to use an M12 thread to actually thread it in the inside there. Now, before actually starting it, I printed out this 3D little model of the plunger. So it's only going to be that big. It's quite small when you actually make it over there. And then to actually get the proper size of the actual plunger, you know, is to make sure that it fits in there pretty tightly, as you can see. This works out to about 17.45, 17.5, around about there. This end bit over here, but like I say, it's actually got to be made to fit over there. Then just a side note, if you saw the video before, if you haven't, please go and have a look at it. I'll leave a link at the top there. I ordered new sensors to go in here because the last one broke, and I mentioned in the last one, I think it was the thread size was something like 1.25, but interesting enough, when I got the new sensors, the thread pitch wasn't that, it was actually 1, and the sensors were actually a much higher quality. So I actually had to rethread this, and I just rethreaded the one that was there, so I just threaded over it, and it seems to be working fine. But this back one did back out, so I've remade this back one over here to the new pitch, so just be aware of that. In the video, I did leave a description, or sorry, not a description, a link to the actual thread I used before. So just be cautious there and make sure about the actual tap you're going to use matches the thread on the sensor you got. The 1.25 pitch seems to be a much lower quality of sensor compared to the one with the pitch of the 1. This is the one that broke. And yeah, the new ones are actually a much higher, as I say, much higher quality. But let's head over to the lathe and let's make this part over here. Okay, so this is the end result, is this over here. I think it came out pretty well. I think the advantage of making a separate, let's call the, well, it's called the plunger, but let's call the tip of the plunger, the whole shaft and everything, is that should I at any point wish to increase the size here or bore this all the way down to the bottom, I just have to remake this part and not the connector that goes between here and the actual pneumatic press itself. So this does fit over here quite nicely. Yeah, it sort of grabs in there and then pushes down. But let's see what happens. Time will tell, and let's see what type of tolerance you actually need on this hole over here. I sort of turned it down to 1 point, and then I actually sanded it down to get to this final tolerance over here. And you can already see this, I don't know if you can see it, there's slight scorching occurring there where it's getting caught up on the chamber. But I think that's sort of what you want, because this is obviously conforming to the shape of the chamber, but obviously time will tell. So guys, that's the plunger over there. It's I think it's a better design than making the whole thing in one go, because this is obviously replaceable, and should I decide to change the inner diameter of the actual chamber, I only have to make this again, not the entire connection shaft to the pneumatic ram. So yeah, and it's made of dissimilar metals, so it should resist actually getting jammed inside the chamber itself. So next up, I'll be making the actual connector from here to the ram. I've got the ram on back order, so just waiting for that to arrive, and then I can actually start that. So please consider subscribing, and then you can follow along in this series, and I'll catch you in the next one.